This is the 2025 Higher Level Applied Maths Solutions question 2. A particle of mass m moves vertically upwards through the air with displacement and velocity, with displacement s and velocity v. Its motion may first be modeled by ignoring air resistance so that it has constant acceleration a. At time t is equal to 0, the particle has velocity v0, which is equal to 4 meters per second, and displacement s0 is equal to 0. Using the chain rule, show that a is equal to v dv ds. Okay, so we know that a, the acceleration, is the rate of change of velocity with respect to time, so it's dv dt. So all we've got to do here really is, as they say, use the chain rule. So we're going to split this dv dt up like this, and then we've got to put something here that will cancel. So let's see, what can we put? Well, we need a ds in this. So I'm going to put ds here and ds here. So dv ds is what we need in the answer. And then ds dt, that's the rate of change of displacement with respect to time. That's just velocity. So we're really there. I mean, we have velocity, that's velocity there. And then we have dv ds as well. So that's it. Okay, next question then. Use calculus to derive an expression for v in terms of a and s. Well, they started us off in the previous question with the expression, or with the equation, a is equal to v dv ds. So this is where I'm going to start. So what I'm going to do first is just separate out the variables here. I'm going to multiply across by ds. So we've got a, which remember is a constant, ds is equal to v dv. So what I'm going to do now is just integrate both of them. So I'm going to integrate a with respect to s, and then integrate v with respect to v. So what I'm going to do is put in the limits here as well. We're told in the question that when the velocity is 4, the displacement is 0. And remember as well, we need an expression for v in terms of a and s. So I'm going to put a v up here and an s here. So let's just work through this then. If you integrate a with respect to s, a is a constant, remember. So you're just going to get a s, and then we're going to put 0 here, s here. If you integrate v with respect to v, you're going to get v, increase the power by 1, so that's v squared divided by the power over 2, with the 4 here and the v here. Okay, so let's just stick in our limits. So we've got, let's see, a, substitute in the s, subtract a, substitute in the 0. We've got v squared, so substitute in the v, that's going to be just v squared over 2. Substitute in the 4, so that's going to be 4 squared over 2. Now on the left hand side we're just left with as, a times 0, 0. On the right hand side we've got v squared over 2 minus, here we've got 4 squared, which is 16, divided by 2, which is 8. Now it says, what does it say up here? It says derive an expression for v in terms of a and s. So we need to get v on its own. So let's get rid of that 8 anyway. So it's going to be as plus 8 is equal to v squared over 2. Multiply both sides by 2, so you get 2as plus 16 is equal to v squared, and then just square root both sides. So you get the square root of 2as plus 16 is equal to v. And I think that is it. Yeah, that's it for that part of the question. Okay, next question. The model may be improved by including the force due to air resistance as 1 over 40 mv squared. Show that the upward motion can now be expressed by the differential equation, that thing there. So we have our particle, and the particle has two forces acting down. One is air resistance, so that's acting down in this direction, and it has a magnitude of 1 over 40 mv squared. Now the other one then is its weight, which is just mg, and there's acceleration then in this direction. So let's have a look at writing down an equation with all these forces. So we have the forces downwards would be minus mv squared over 40, and then also minus mg, its weight, and that should be equal to its mass times acceleration. So its mass we don't know, and its acceleration. So what we can do first here is just get rid of the masses. So we've got minus v squared over 40 minus g is equal to a. Now we need to write an equation with a ds in it, a v in it, a dv, and a v here. So I'm going to change this acceleration to v dv ds. So I've got minus v squared over 40 minus g is equal to v dv ds. Okay, so this is what we're going to be working with. I'll just come over here a little bit. So the first thing I'm going to do is multiply across by ds. So that'll give me minus v squared over 40 minus g, and all of that is multiplied by ds. And that's equal to v dv. The next thing I'm going to do is just get the v's on their own on one side. So I'm going to leave the ds on the left hand side, and on the right hand side then I'm going to divide that v by minus v squared over 40 minus g, and that's dv here. So I've now got the ds's on one side and the v's and dv's on the other side. Okay, so next thing I want to do is maybe have a look at these two fractions here, add them. So ds is equal to v over, common denominator here is going to be 40, so that's minus v squared minus 40g, and that's dv. Okay, so I'll just come up here now. Let's see, we're going to flip this upside down, multiply. So we have ds is equal to 40v over minus v squared minus 40g dv. Okay, so I'm kind of stuck now. So what I'm going to do is just go back to what we need to find. This is where we need to end up here. And I notice here with the ds we've got a minus 1 over 20. So what I'm going to do is multiply both sides by minus 1 over 20 and see what that does for us. So I've got minus 1 over 20 ds. So at least I know I have one side correct. And then minus 1 over 20 here on the right hand side multiplied. So the 20 will divide into the 40 twice. So it'll be 2v, and it'll be minus as well. And then on the bottom, I've got minus v squared minus 40g dv. I've got minus 1 over 20 ds on the left hand side. On the right hand side, what I can do is multiply the top and the bottom of this fraction by minus 1. So that'll leave me with 2v on the top, and multiply the bottom by minus 1 as well. That'll leave me with v squared plus 40g dv. Now finally then on the left hand side I've got minus 1 over 20 ds. So on the right hand side I've got 2v, and then I've got v squared plus, if you multiply 40 by g you will get 392. And that's dv, and that is it, I think. Minus 1 over 20 ds, and then we have 2v over v squared plus 392 dv. That's it. So that's it for that part of the question. Solve this differential equation to find an expression for v in terms of s. Okay, so our equation was minus 1 over 20 ds is equal to 2v over v squared plus 392 dv. So we've got to solve this. So what I'm going to do is integrate both sides, and I'm going to stick in limits as well. We know that the velocity was 4 at 0 displacement. I'm going to put v here again and s here. So let's solve let's work out the left hand side first. So 1 over 20 ds will just become minus 1 over 20s, and we've got to put in our limits here from 0 to s. Now this one here I'm just going to do separately, so let's do that over here. So we want to find the integral of 2v over v squared plus 392 dv. So what I'm going to do here is let u equal to v squared plus 392. That'll give me du dv is equal to 2v, and then du is equal to 2v dv. So we can see we have a 2v dv here, and this will be our u. So what we'll end up with is finding the integral of 1 over u du, and we know that that's just log u. So when we integrate this here, well, it's plus c as well, but I'm going to be sticking this back into a definite integral, so I'm not going to worry too much about the c here. So what I'm ending up with here on the right hand side, when I integrate this fraction here, I end up with the log of v squared plus 392, and the limits are 4 to v. I've just substituted back in here. Okay, so let's work all this out then. So I've got minus 1 over 20s minus 1 over 20, minus actually, which is plus, and 0. On this side here, I've got the log of v squared plus 392 minus the log of 4 squared plus 392. Okay, on the left hand side, I've just got minus 1 over 20s. On the right hand side, let's see, I've got subtraction here, so I can divide these two here. So in other words, I end up with the log of v squared plus 392 over 4 squared is 16. Add that to 392, and you will get 408. So what I'm going to do next is just convert this from log form to index form. So we end up with e to the power minus 1 over 20s is equal to v squared plus 392 over 408. So I'm going to multiply across by 408. So that will be 408 e to the power minus 1 over 20s. I'm also going to subtract this. So it's minus 392. That gives me v squared. So finally then I just need to square root both sides. So I get the square root of 408 e to the power minus 1 over 20s minus 392. Okay, next question then, calculate the greatest height the particle will reach. Okay, so we're going to use this formula that we've just worked out. So v is equal to the square root of 408 e to the power of, let's see, s minus s over 20 minus 392. So at the maximum height, the velocity will be 0. So I'm just going to put 0 in here. I'm going to square both sides at the same time. So I'll get 408 e to the power minus s over 20 minus 392. So, okay, we just got to solve this for s. So what I'm going to do is bring this over to the other side and then divide by 408. So I've got 392 over 408 is equal to e to the power minus s over 20. Now if we get the log of both sides, we've got the log of 392 over 408 is equal to, well, if you get the log, the natural log of this side, you just end up with minus s over 20. So all I've got to do now is multiply by minus 20 both sides. So I get minus 20 log 392 over 408 is equal to s. So if you do the left hand side, what you'll end up with is 0.8001066,923. So that's equal to s. But I think if you wrote 0.8 in the exam, 0.8 meters, I think you should probably be okay, hopefully. It doesn't say how many decimal places to give this. So by using a is equal to dv dt, solve the differential equation to find an expression that relates v and t. So the equation that we have from previous part of this question that involves a is equal to minus g minus v squared over 40. So we're told that a is dv dt. So what I'm going to say here is dv dt is equal to minus g minus v squared over 40. So what I'm going to do is just separate out some of these variables. So I'm going to take the minus g minus v squared over 40 and divide it across and bring the dt over to the other side. So on the left hand side I'll have 1 over, Well, actually what I might do this time around is bring over g plus v squared over 40, and that's dv, and leave the minus on the right hand side. So on the right hand side I should end up with minus dt. Now what I'm going to do is integrate both of these. So on the right hand side I'll just end up with integrating with respect to t, so it's just going to be t. It's an indefinite integral, so it's going to be plus c, and it's actually a minus t as well. So on the left hand side what I'm going to do is just add these two fractions, which will give me the integral of 1 over 40 on the bottom, so that's 40g plus v squared, and then I'm just going to flip that upside down. So I'll end up here with 40 over, let's see, what is it, 40g plus v squared, and that is with respect to v, by the way, so that's dv, and on the right hand side again minus t plus c. So on the left hand side I will just get 40 over 40g, again is 392. So I'm going to put the v squared here, and what I'm going to do is write down the square root of 392, which is 14 root 2. So I'm going to write down 14 root 2, which I'm going to write down as being squared. What I'm actually going to do as well is take that 40 and bring it outside the integral. So I'm going to leave 1 there and put the 40 out here. That's with respect to v, and then it's minus t plus c on the right hand side. Now the reason I did this bit here was because there is an integral in your tables. It is the integral of x squared plus a squared, and that is 1 over a tan inverse x over a. So I'm going to use that particular integral here. So it's 40 times. When you do this integral here, you should get 1 over 14 root 2. That's the 1 over a, and then it's tan inverse x over a, or in this case v over 14 root 2. So that's the left hand side, and on the right hand side it's minus t plus c. Okay, so if I multiply that 40 by this fraction here, what I'll get is 10 root 2 over 7, and that's tan inverse v over 14 root 2 is equal to minus t plus c. Okay, so the next thing I'm going to do is just work out what c is. So we're told in the question that when v is equal to 4 meters per second, t is equal to 0. So we can just substitute those values in here. So you got 10 root 2 over 7 tan inverse v, we're saying is 4 over 14 root 2 is equal to, well, t is 0, so we just have c here. So all you've got to do here really is do all of this on your calculator, and you should get 0.4027421782. Remember that we're dealing in radians here. So that will give us our equation as 10 root 2 over 7 tan inverse v over 14 root 2 is equal to minus t plus 0.4027421782. Okay, so we've just got to isolate v. So what I'm going to do here first is I'm going to multiply both sides by 7 and then divide by 10 root 2. So that'll leave me with tan inverse v over 14 root 2 on the left hand side, and then on the right hand side you should end up with minus 7t plus 2.819195248, and we need to divide then by 10 root 2. Okay, so next thing I'm going to do is just divide 10 root 2 into the minus 7 and the 2.819 and so on. So leave me with tan inverse v over 14 root 2 on the left hand side, and on the right hand side you should end up with minus 7 root 2 over 20t plus 0.199347277. Okay, so what we need to do then is, if tan inverse of this is equal to all of this here, just means that if you find the tan of this here on the right hand side, you'll get v over 14 root 2. So v over 14 root 2 is equal to the tan of all of this on the right hand side. Okay, and then finally we just need to multiply both sides by 14 root 2. So that'll finally give us a V is equal to 14 root 2 tan of, I'll put the positive number first, 0.199 minus 7 root 2 over 20t. And that's it for this question.